Morning everyone. Can you hear me?
স্যার স্যার সাউন্ডটা ভালো করে আসে।
Am I audible now?
ইয়েস স্যার।
Now sound is clear from your side. Hello. Hello. Am I audible? Now
ইয়েস
can
স্যার।
Yes,
ইয়েস
sir.
স্যার।
Okay, let us start our today's class. Let me not know whether it is visible or not. Let's screen.
ইয়েস স্যার, ভিজিবল স্যার।
Okay. So you can see here in the question that question came in here 2016 exam. So the first question of today's class is that the correct combination of pi and pi star orbital in B2 molecule is what? That question also basically came from molecular orbital theory, but molecular orbital theory, but question is asking correct combination of pi pi star orbital in B2 molecule is Birad, 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 Birad. আচ্ছা, তোমাদের এই কনসেপ্টটা মনে আছে যে হোয়াট ইজ কল ডিরাইভড সিমেট্রি আনডিরাইভড সিমেট্রি? মনে না থাকলে বলো, তাহলে আমি বলে দিচ্ছি ডিটেলস।
স্যার একবার বলে দিলে ভালো।
Yes. So, so Gilead and Ungilead basically they are basically from came from German words. So Gilead means even and Ungilead means odd. So now, if you look at here as the question is asking for Gilead and Gilead symmetry, so you have to determine the symmetry of both the pi and pi star orbital of B2 molecule with respect to the center of symmetry. Now first what you can do, you just write down the MO electronic configuration of B2 molecule. So what is the MO electronic configuration of B2 molecule? It is sigma 1s2, then sigma star 1s2, sigma star 1s2, then you have sigma 2s2, sigma 2s2, then sigma star 2s2, sorry it is s2, then you have pi 2px, pi 2px 1 equals to pi 2p y1 because they are in a degenerate state, and then you have uh, sigma 2pz, then who is this? Okay, then pi star to py, sorry, pi star to px and pi star to py, px equals to pi star py, then you have sigma star to pu. So this is the overall chemoelectronic configuration of B2 molecule according to molecular orbital theory. So here you can see that they are asking about the pi and pi star orbital. Okay, so pi means you have you can see here that pi to px and pi to py orbital, and pi star to px, pi star to py orbital. Now we are going to draw the molecular FMO, frontier molecular orbital. So here you can see that if you consider this is one boron, another boron is present like this. Now the pi star orbital, that means, so one is present like this, and their symmetry would be, let's say if you consider it is plus, it is also plus. On the other hand, another lobe that is basically present in minus in this particular format. Now if you compare, we just interconnected this. Now if you consider, you can see that there is a center of symmetry present over here. I is there. Now based on the I symmetry, you can see here the pi square orbital is basically that symmetry. Okay, that symmetry. Okay, because if you try to draw a line from this part to this center and extrapolate this line on the opposite side, you will get the similar kind of positive charge over here. So therefore it is a clear symmetry. On the other hand, if you look at the pi, normal pi bonding orbital, like you have like this, when they will form the pi bond, what happens? You can see here it is plus, minus, another pi bond, Tx, or you can say Ty z orbital like this. Now when they combine themselves like this way, they will form this kind of pi orbital. Now after formation of pi bonding, how can you represent this thing? So there is a positive charge is delocalized with respect to this particular center axis, bond axis, there is positive charge, and in the below there is a negative charge. So that means this is all about unpaired symmetry. Okay, unpaired symmetry. So therefore, we can see that the option B, that is, you can see here pi orbital is an unpaired symmetry, and pi star orbital is an paired symmetry. So option 2 is the correct answer. Is it clear? Yes or no? Rahul?
Yes, sir. Yes, sir.
Okay.
Yes, sir.
So next, coming to this particular another question, that question also came in NET 2016 exam. So question is asking the correct shape of tellurium pentafluoride minus ion on the basis of BSEPR theory. BSEPR theory. So all of you please try to solve this problem within 1 2 minutes. BSEPR theory. Your central atom is tellurium. So you just find out the total number of valence electron present in this particular compound, and then how many number of bond pair is there. So, and another main important thing is that how many out of this electron pair, how many number of bond pair electron and how many number of lone pair electron is there, and accordingly you just try to draw the geometry as well as shape of this particular anionic species. So first,
SP3D2 এটা application-টা।
sure, sure,
Yes, sir.
yes. So how many
SP3D2
number
sir.
of lone so how many number of lone
One,
pair
sir.
and how many number of
One lone pair.
one lone pair? Okay. And how many number of one pair?
Sir, 5.
Yes.
5 bond pair.
So yes, yes, yes. Very good. Now you just try to say what is the correct answer out of these four options.
Square pyramid.
Square pyramidal.
Yeah,
Square pyramidal.
it's square pyramidal is the correct answer. Very good. Very good. So you have tellurium over here. Now pi chloride is directly interconnected with the central tellurium atom, right? And another chlorine is present in the axial side of this particular geometry, and another side is occupied by this lone pair of electrons. So this is the structure, and you just put over negative charge over here. Very good. So next question is, yes, the expected hydrogen bond angle in H3 plus ion is what? This question is not at all easy question. Okay, you just think before the answer. H3 plus ion. Or both.
স্যার এটাকে 180 ডিগ্রি হবে।
How? Is it linear? Molecule is linear. H3 plus H3 plus ion. Is it linear? Anybody?
Sir, 60 degree.
How? How? Anyone?
স্যার ওটার শেপটা স্যার ইকুইটোরিয়াল ট্রায়াঙ্গেল।
Equatorial, not equilateral. Right? So that means this H3O plus ion is a combination of hydrogen and one H plus ion. Okay. Now, how can you trace this particular fact? You can see here, as you know, the H2 is linear. So therefore, you just try to draw its H and H, and another H plus. When they will interact with this H2, they will form a kind of, okay, short interaction between hydrogen and. Now, if you just try to draw here, the angle that H angle means the angle like this angle. Okay, that angle that means is 60 degree. So option C is the correct answer. Is it clear? Proud?
স্যার এটাকে লিনিয়ার স্ট্রাকচার হইতে পারতো না? মাঝখানে যদি
না,
H প্লাসটা থাকে আর দুই সাইডে দুইটা H।
হবে না তো।
আচ্ছা
এগুলো জেনারেলি এই যে অ্যাটমিক যে আয়নগুলো, অনেক সময় দেখো না যে কোনো একটা জায়গায় যদি ডবল বন্ড থাকে, ধরো একটা অ্যালকিন, এখানে তুমি H প্লাস অ্যাড করেছো, তখন সেই H প্লাসটা কিভাবে ইন্টারঅ্যাক্ট করে? এভাবেই করে, প্রথমে একটা ইন্টারমিডিয়েট স্টেপ তৈরি হয়, তাই না? লাইক
ইয়েস
দিস,
স্যার।
সেইভাবে ডট 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 H প্লাস, তারপরে অন দ্য বেসিস অফ রিয়াক্ট intermediate, they provide the product, right? Serial kind of intermediate is also forming over here. And the expected bond angle of this hydrogen, this and that, it is around 60 degree. Very good, minimum. Okay, coming back to the next question. Yes, that question is very important. The geometry of rhenium H92 minus. What is the geometry? Anybody?
স্যার sp3d4 মানে এটা হাইব্রিডেশনটা।
Sp3d4. Okay. Okay, if you are saying that it is sp3d4, then what is the geometry then? The name of this particular compound is nonhydrido-renedianion. Okay, rhenium. So the coordination number over here of the central rhenium is 9, and its structure is tri-capped trigonal prism structure. Okay, tri-capped trigonal prism structure. So it is there in that book. What is that? Inorganic chemistry book by
স্যার এটা কি ভিএসিপি এতে করণ যেত না এটা?
yes, yes, it is possible. You are saying that the hybridization is sp3d4.
4.
Okay, if it is sp3d4, it is last time yesterday I have already mentioned one compound like IF
Yes, yes. Coherent prism.
square
compound.
antiprism. But here the geometry of this particular molecule is tri-capped trigonal prism. So if you just look at here, yes, the option C is the correct answer. I just want to show you the structure. Okay, structure of this particular compound. If you Google it, you can automatically see that structure. Okay, just only structure. Okay, I just want to stop the sharing. Stop the generating. And share another screen. Yes. So is it visible?
Yes, sir.
Yes, sir.
Okay. Just wait. Copy. Text over here. So is it visible? So this is the structure, or you can see here. It is already here in Google. You just type it. The structure of RE. It is the structure, and what is the geometry? It's geometry of tri-capped trigonal prism geometry. Tri-capped trigonal prism geometry. So if you just consider this bottom part, these two hydrogen, three hydrogen, it makes one trigonal prism type of fragment, and another this three hydrogen makes another, and rest of the other these three hydrogen they will present like this, and the geometry is tri-capped trigonal prism. You just remember all those things. Next question is came in NET 2017 exam. The question is asking the fast ionization energy is the lowest for which atom? Bromine, phosphorus, selenium, arsenic. The fast ionization energy is lowest for which atom? So ionization energy means the amount of energy required to remove the valence electron, right? Now what you can do, you just, so bromine, as you know, the atomic number of bromine is 35, right? So 35, and accordingly the valence electron configuration of bromine is 4 is to 45, right? 4 is to 45. Accordingly, Tell me the answer if you know.
Arsenic, sir.
Arsenic.
Yes, sir.
Okay, selenium is also the atomic number is, yes, here is 34. Then it is again 4 is 2, 4 is 4. And arsenic the atomic number is 33, and their corresponding valence electronic configuration is 4s2, 4p3. Now, if you look at their valence electronic configuration of 4p orbital, you can see that in case of bromine, the p orbital contains total 5 electrons, like this. In case of selenium, 4 electron is present, like this. 1, 2, like this. And in case of arsenic, it is a half-filled electronic cell, right? And more stable.
Yes, sir. Selenium. Answer correct.
Yes, more stable. But the fast ionization energy is lowest. Lowest, it is selenium. Why? Because removal of this electron, it will, yes. So after removal of this electron, that selenium will get this half-filled electronic configuration, right? That's why it, the less amount of energy required. Yes, yes, yes. Selenium is the right answer. Very good. But the highest amount of fast ionization energy, if you just look at here, in case of fast, you look at the electronic configuration of the valence shell of each of these particular atoms, and you can easily say that phosphorus is having highest ionization. Okay. Next question. Yes, that question is very good question. You can see here, came in 2017 net CSR exam. Among the chlorate, xenon trioxide, sulfur trioxide species with pyramidal shape, is and are. This is quite logical question. You can just try to give the answer. So as you know, xenon trioxide, I have discussed several times the structure of xenon trioxide. It has pyramidal structure. It has pyramidal structure. One lone pair is present, like this, with pyramidal shape. Now you can see here, xenon trioxide, it has pyramidal shape. Yes or no? On the other hand, if you look at the structure of sulfur trioxide, what is the structure of sulfur trioxide? This is the structure, right? Trigonal planar, and central sulfur atom is sp2 hybridized. So it is not acceptable. And finally, the last one, the chlorate ClO3 anion. What is the structure? ClO3. You have chlorine. Now the central atom is chlorine and oxygen O3 minus. So therefore, from chlorine you will get 7 electron, and from oxygen, how many? So for each oxygen you have to 1, so 3, and for pi bonding -3, and for one negative charge it is +1. So therefore, overall the total number of electron is 8. The bonding electron pair is 4. So therefore, the corresponding hybridization is sp3. So therefore, out of sp3, you can see here there are total central atom is chlorine, and there are total three oxygen is present like this, and you have one lone pair will be present, and overall it is negative. So the option one is the correct answer. Is it clear?
Yes, sir.
Yes, sir.
Okay. I think option one is correct. Yes. So coming to the next question. Find out the geometries of SNF3 and HCF2O2. What is the answer? So first you consider this one F2O, it is xenon. You place two fluoride atom in the axial side, and two oxygen place in the equatorial side, and one lone pair will be present like this. This is the structure, right? And what about ASNF3? So as the what is the geometry then? It is trigonal bipyramidal. You can see here option 3 and option 4 is yes. So you just cross the first and second one. The trigonal bipyramidal is matching with XeF2O2. Then you have to find out what is the actual geometry of SNF3. SNF3. YOLO.
So tetrahedral.
Tetrahedral.
Yes, sir.
How?
Sir, hybridization to the sp3 আসে sir.
How? How it is just. Yes, Rahul, your answer is correct, but how you have to understand? Okay.
Sir, nitrogen का जो central atom ধরে তো nitrogen balance 5 হবে.
Okay, nitrogen. Okay, central atom. So it is what is 2s2, 2s2, 2p3, right? Yes
Yes,
or
sir.
no?
Yes, sir.
Then this is the ground state electronic configuration for the just yes. So that means so it is 2s2 and 2p3 like this. Okay. So now you can see here there are total 3 chlorine atoms there. So for that 3 chlorine atom, 3 unpaired electrons there. But what about sulfur? So this is the ground state. Now if you excite the one electron form 2s2, that the vacant cell 1:2:3:6. That is,
স্যার এদিকে কি এন এর কি ভ্যাকেন্ট ডি অরবিটাল তো নাই স্যার।
yes, there is no vacant d orbital. Then how can you do that? According to Valence bond theory, yes. So that means here sulfur is the central atom, not nitrogen. Okay. So sulfur is the central atom. So accordingly, it is 3s2, uh, 3s2, 3p4, right? Yes, 3s2, 3p4. That means like that. Now, so in case of sulfur, as you know, there is a d orbital, vacant d orbital. So for that case, so if you excite one electron from two electron, one from 3p and another from 3s, so you will get overall total 5 until electron. Okay, 5. Now here you can see that one fluorine, it will donate 6 electron, valence electron, and it will form one sigma bond, and another fluorine is also doing the same. That is, another is there. Okay. Okay, another electron is there. Now you have nitrogen. So in the nitrogen, how many valence electron is there?
5
There
স্যার।
are, no, in general, you can see that 3s2 3p3. That p electron, 3p electron, if it donates here, it will form one sigma bond and another pi bond, like this, 2 pi bond. Well, so for that case, as you know, according to valence bond theory, during the consideration of hybridization calculation, this part will be excluded, so overall hybridization is sp3. So accordingly, the corresponding geometry is sulfur. There is a triple bond present like this, and 3 fluorine is present like this, and the geometry is tetrahedral. Is it clear, Rahul? Now,
ইয়েস স্যার।
is sp3, and therefore the geometry is tetrahedral. Saurabh, Mausuninath, any doubt? Paulomi, Dev, Pranjit, any question?
No, sir.
Pranjit বিশ্বাস, বোঝা যাচ্ছে তো জিনিসগুলো নাকি? Okay, next question. That question came in the NET 2017 exam. Boron in boron chloride has sp hybridization, sp2 hybridization, sp3 hybridization, no hybridization. So option 2 is the correct answer, right? This is sp2 because you know it has trigonal planar structure, right? Chlorine, chlorine, and the central atom is sp2 hybridized. Clear? So next.
ইয়েস স্যার।
Okay, that question you can see here. I have already told several times during the class what is Benz rule. So according to Benz rule, for p-block elements, the correct combination of geometry around the central atom and the position of the more electronegative substituent is what? According to Benz rule, for p-block elements, the correct combination of geometry around the central atom and the position of the more electronegative substituent is what? Trigonal, bipyramidal, and axial. Trigonal, bipyramidal, and equatorial. Square pyramidal, axial. Square pyramidal, basal. Which option is the correct answer? It is trigonal, bipyramidal, and axial because Benz rule, that rule is only applicable for PDP geometry, right? trigonal bipyramidal geometry. And the more electronegative elements may be present in the axial side of this negative geometry. That is what is called benzene. So option A is the correct answer. Ranjit, তোমার কথা শোনা যাচ্ছে না। Anyway, the next question is the question came in 2015 exam. You can see here the geometries of BR3 plus and I5 plus. Okay, tell me the answer. Rahul,
Yes, sir. It was.
okay, do first, do first. একটা কোশ্চেনের বিষয়ে তোমাদের টাইম নেওয়া উচিত ম্যাক্সিমাম 2 থেকে 3 মিনিট। গৌরব,
Sir, first tetrahedral.
first one is tetrahedral BR3 plus.
Sir, option B, B number.
Tetrahedral and trigonal bipyramidal.
Answer.
BR3 plus.
Sir, option 4.
Linear and trigonal bipyramidal. Yes, option 4 is the correct answer. Very good. তোমরা জানো তো স্ট্রাকচার অফ I3 প্লাস এর স্ট্রাকচার কি? লিনিয়ার হয় না, লিনিয়ার শেপ, রাইট? সিমিলার ওই BR3 প্লাস একই হবে, কারণ ব্রোমিন এখানে আছে সেন্ট্রাল, আর আরেকটা ব্রোমিন এখানে থাকবে, একটা অ্যাক্সিয়াল সাইডে থাকবে, আর তিনটে লোন পেয়ার ইকুয়েটরিয়াল সাইডে থাকবে। এই তো হয় ওভারঅল প্লাস যায়। And in case of I5, this is plus, I think, or minus. What do you say? It is I5 plus, I think, yes. I5 plus. So therefore, if you just try to draw, so iodine 7 from another 4 iodine, it is 4 for positive charge minus 1. So therefore, is 7 plus 4, 10. 10 divided by 2, so it is 5. So hybridization is sp3d, and it has trigonal bipyramidal. Trigonal bipyramidal geometry. Yes, trigonal bipyramidal is massive, but what about BR3 plus? So let's say 1 is central atom, 7, and 2 is from 2 electron coming from 2 bromine, and for positive charge it is minus 1. So 7 plus 2, 9 minus 1, so it is 8. Now as it is 8, so it is divided by 2, so it is 4. So that basically indicates the sp3. Okay, if it is sp3, then it is tetrahedral, right? Tetrahedral. So then what is the correct option? Tetrahedral and trigonal bipyramidal, or linear trigonal bipyramidal? So we have already know the structure of I3 class ion, right? So for that case, what is the geometry? Iodine from here also
স্যার এটা
7 plus,
স্যার ভি শেপ হবে,
sorry,
ভি শেপ হবে স্যার, I3 প্লাস।
I3 plus B shape. Okay, anyway, that means that option 2 is the correct answer, okay? Not linear. It's clear. Next,
Yes, sir.
the structure of XCF2 and XCO2F2. Very easy. So just now I have solved that the structure of XCO2F2, right? So xenon in 2 chloride atom is present in the axial side of TBB geometry, and 2 oxygen is present like this, and 1 lone pair present like this. So it is seesaw type of structure, right? And on the other hand, in case of xenon dichloride, as you know, here's this structure.
It is linear structure, sir.
Yes. C lone pair is basically present. So linear and seesaw. Right? Option C is the correct answer. Very good. Next. So the molecule P3O2 has linear structure. This compound has 4 sigma bond, 4 pi bond, 3 sigma bond, 2 pi bond, 2 sigma bond, 2 pi bond, 3 sigma bond, 4 pi bond. Do you know what is the name of this compound? It is tricarbon dioxide. There is another name of this particular compound, that is called carbon suboxide. Okay, so carbon suboxide. Now, as it is already mentioned that linear structure, so that means you have put 3 carbon in this way, and another 2 oxygen is present like this. Now here you can see there is 1 sigma bond, one sigma bond, another sigma bond. There is a pi bond present in between. That means it has total 4 sigma bond and 4 pi bond. Okay. So next question, the correct statement among the following. That question came in Jan 2015. This is also you have to solve with the help of molecular orbital theory and the molecular diagram of dinitrogen molecule, right? Nitrogen has higher bond order than N2 plus and hence has larger bond length compared to N2 plus. Okay, first what you can do, as you know the bond order of nitrogen molecule according to the molecular orbital theory, it is 3, right? So what is the bond order of N2 plus ion? So I think it is 2.5, right?
Yes, sir.
It is 2.5. So therefore, if you look at the option 3, that nitrogen has higher bond order than N2 plus, yes, it is matching, and hence higher dissociation energy compared to nitrogen. Yes. So bond order is directly proportional to the bond dissociation energy, or you can say bond energy. So therefore, option 3 is the correct answer. Simple way you can easily solve this kind of problem. Now the next question is, you can see here the number of lone pairs of electron on the central atom and this, and SbCl6 3 minus, antimony hexachloride 3 minus. So as you know, the structure of xenon hexafluoride is it has distorted octahedral structure, and it contains one lone pair, right? So XC F, another fluorine is there, it is there, another it is there, and the lone pair is basically present in the interstitial position of this distorted octahedral geometry, right? Now, if you just try to calculate the bond pair and lone pair electron in case of Br F4 minus. So from bromine it is 7 plus from chlorine it is 4 for one negative charge, so it is 1. So it is
2,
12
sir.
divided by 2,
Lone
so it
pair
is
two.
6. So that means 2 lone pair. Okay, 2 lone pair is matching. Now then, yes, you crossed option 2 and option 1, right? Then the final one, that is SbCl6. SbCl6 3 minus antimony. Nitrogen, phosphorus, arsenic, antimony, bismuth. The antimony it is 5 plus from 6 chlorine it is 6, and from 3 negative charge, so it is 3. So it is 14 divided by 7, divided by 2, so it is 7, right? So 7 means it is sp3 what? E3. And you can see here there are 6 chlorine, so 6 bond pair and 1 lone pair. 6 bond pair, and so option C is the correct answer. Here, so yes, that question also came in JAM 2015 exam. The question is asking the ground state electronic configuration of C2 using all electrons. You can see here the molecular orbital electronic configuration of carbon C2 molecule you have to find out. So what is the exact electronic configuration of C2 molecule? Anybody? So carbon means is C2 molecule means it is 12 electron species, right? So therefore, so it is sigma 1s2, sigma star 1s2, right? So it is sigma 1s2, sigma star 1s2, then sigma 2s2, then sigma star 2s2, and then what? Then make
Option 4, sir.
then sigma 2pz, yes, sigma 2px, it is 2, right? So 2 to 4 to 6 to 12, 2 to 4 to 6 to 8 to 10, sigma 2px2, then you have you're saying that 5 to p4. Yes, yes, yes. Pi is fully, so that's why C2 is diamagnetic in nature, right? So it is pi 2p. This is 2 equals to pi p y2. So yes, so option 4 is the correct answer. Very good. Next, the molecule of diboron belongs to the symmetry point group what? Diboron B2H6. It has 3 center 2 electron bond system, right? This is the structure of diborane. So you can see here, C2 is the principal axis of symmetry. There is a perpendicular C2 axis is there. Then you have sigma V along the C2 axis, and another sigma is there. So what is the final group then?
P2A.
P2H. Yes. Next, the correct non-linear isostructural pair. Non-linear, you can see that. Isostructural pair. Okay, time is already over. So next couple of questions is already there. So I will discuss in the next week. And after that I will start this main point, that is main group element and their compounds. Questions from main group elements and their compounds, and followed by lanthanides and actinides. Okay, any question after this? Any problem? So all of you please give your attendance. Go to the chat box and give your attendance. So any question? Hello.